Hello, welcome to today's lesson on solids, liquids, and gases. You will need a copy of your solids, liquids, and gases guided notes for today's lesson. Today's success criteria is to be able to classify material as solids, liquids, or gases and explain their behaviors by using the kinetic theory of matter. Today's vocabulary you're going to need to know are solid, liquid, gas, and kinetic energy. If you were asked to classify some materials as solids, liquids, or gases, you probably could do this pretty easily. But could you describe what method you would use to classify these materials? You might notice that some materials have a definite shape and volume, and some materials do not. Materials can be classified as solids, liquids, and gases based on whether their shapes and volumes are definite or variable. Shape and volume are clues to how particles within the material are arranged. Think about a cell phone charger. It has a recognizable shape and it takes up a certain amount of space. The material in the charger is in the solid state. The solid state of matter, which materials have a definite shape and definite volume. The particles in a solid are tightly packed and usually in a regular pattern. They also vibrate, but generally do not move from place to place. The term definite means the shape and volume of the charger won't change if you move it from an outlet to your pocket, to your locker, or even put it in your box or in a bag or of some sort. Changing the container doesn't change the shape or volume of a solid. One thing to note is that definite doesn't mean that the shape or volume can never change. A pencil can be sharpened, or a wire on a charger can be coiled. It still remains as a solid. Liquids. It's a state of matter in which material has a definite volume but not a definite shape. The particles in a liquid are close together with no regular arrangement and they vibrate, move around, and slide past each other. A liquid always has the same shape as its container and can be poured from one container to another. Gas is a state of matter that has neither a definite shape or a definite volume. Particles in a gas are well separated with no regular arrangement and vibrate and move freely at very high speeds. Gas takes up the shape and volume of the container. Concept check number 1. Question 1. How are the shape and volume used to classify solids, liquids, and gases? Question 2. Describe the shape and volume of solids, liquids, and gases. This would be a great time to pause the video, answer the question, and then resume play. Question 1. How are the shape and volume used to classify solids, liquids, and gases? Materials can be classified as solids, liquids, or gases based on whether their shapes and volumes are definite or variable. Question 2. Describe the shape and volumes of solids, liquids, and gases. Solids have definite shape and definite volume. Liquids have a definite volume and a variable shape. It takes up the shape of the container. Gas, no definite shape, no definite volume. Other states of matter. At extremely high temperatures, like the sun and stars, matter exists as plasma. Plasma is a state of matter which atoms have been stripped of their electrons. Plasma is the most common state of matter in the universe. It is where a gas is superheated. So, if you think about heating water to a boil, superheating the gases causes plasma. It can be found on Earth as well. Plasma torches are used to cut metals in the industry field. The Bose-Einstein constant, or BEC, is another one. In 1920, Satyendra Bose, a physicist from India, wrote a paper about behavior of light. In 1924, a guy by the name of Albert Einstein predicted that a fifth state of matter could exist at extremely low temperatures, negative 273 degrees Celsius. Groups of atoms would behave as a single atom. In 1995, researchers at MIT produced this state of matter and called it the Bose-Einstein constant. Why, at room temperature, is copper a solid, mercury a liquid, and helium a gas? Well, we need to revisit kinetic energy. Kinetic energy is the energy an object has due to its motion. An object that is moving has kinetic energy. All matter is made up of particles, and guess what? All the particles are moving. The chair you're sitting in, the table you're sitting at, even the air you were breathing, you got it, all moving. The kinetic theory of matter says that all particles of matter are in constant motion. Explaining the behavior of gases. Particles in a gas are moving very fast and collide into each other and the container. At room temperature, the average speed of particles in a sample of gas is about 1,600 kilometers per hour. There are forces of attraction among the particles in all matter. In gases, the particles are far apart and moving very fast, so the attractions are too weak to have an effect. The constant motion of particles in a gas allows a gas to fill a container of any shape or size. The kinetic theory, as applied to gases, has three main points. The first, particles in a gas are constant, random motion. The motion of one particle is unaffected by the motion of another particle unless they collide. And forces of attraction among particles in a gas can be ignored under ordinary conditions. Explaining the behavior of liquids. The particles in a liquid also have kinetic energy. They are also more closely packed than particles in a gas. Therefore, the attraction between these particles of a liquid do not affect the movement of particles. In a liquid, there is a kind of tug and war between the constant motion of particles and the attractions among the particles. This tug of war explains the general behavior of liquids. A liquid takes the shape of its container because particles in the liquid can flow to new locations. The volume of a liquid is constant because the forces of attraction keep the particles close together. Because the forces of attraction limit the motion of particles in a liquid, the particles in a liquid cannot spread out, so they fill a container. Think about going to a movie theater and seeing a hot new flick. While you are watching the movie, you and everyone else stayed in their seats. For the most part, just go with it. Although people move around in their seats, everyone remains in just about the same spot during the movie. Everyone has fixed locations and a total volume that does not change. A solid has a definite volume and a definite shape because all the particles in a solid vibrate around fixed locations. The vibration is repetitive back and forth motion. Strong attractions of the particles in the solid restrict their motion and keep particles in a fixed location relative to its neighbors. Each particle vibrates around its location but does not exchange places with any other particle. Concept check number 2. Question 1. What does the kinetic theory say about the motion of atoms? Question 2. Use the kinetic theory and attractive forces to explain why a liquid has a definite volume and has a shape that can vary. Now would be a good time to pause the video, answer the questions, and then come back for the answers. Question 1, what is the kinetic theory say about motion of atoms? All particles of matter are in constant motion. Use the kinetic theory and attractive forces to explain why a liquid has definite volume and has shape that can vary. Particles in a liquid can flow to new locations, but forces of attraction keep the particles close together. This concludes our lesson on solids, liquids, and gases. If you have any questions, please feel free to contact me. Also, don't forget to like and subscribe to my YouTube page.